In this video, I will closely look ideal solution. Subscribe to the channel. Watch the video until the end. Ideal solution. What's ideal solution? I'll answer this question. But before talking about ideal solution, let us discuss what's solution. Solution has different meaning in different subject. For example, the meaning of solution in mathematics different from the meaning of solution in chemistry. And solution has different meaning in chemistry and social life. In this video, I'll talk about the meaning of solution in chemistry. Solution in chemistry has two components. The first one is solid, which is the minor component of the solution. The second one is solvent, which is the major component of the solution. Solution is a homogeneous mixture. Dissolution involves three process. Dissolution means formation of a solution. That means formation of a solution involves three process, namely solid-solute interaction, solvent-solvent interaction, solid-solvent interaction. These three interactions must be happen to form a solution. Each interaction accompanied by an enthalpy change. Now let us discuss the first step. The first step here is that solid particles separate from each other. To separate the solid particle, it involves breaking intermolecular force that exists between solid particles. So the process is endothermic process. Now this one is a solid particle. They are aggregated together. They are packed together. To separate the solid particle, we need to exert heat. Finally, the solid particle separated. As we see, the solid particle here is separated and they are far apart each other. Solid aggregated plus heat, solid separated, and the process is endothermic process because heat of a solid is greater than zero. The second step, the solvent particles separate from each other. Again, it involves breaking the attraction force that exists between solvent particles. So the process is endothermic process. This one is solvent particles. As you have seen, the solvent particle here is aggregated. Therefore, we need to exert heat to separate the solvent particles. Now, the solvent particles separated, and its particles are far apart each other. Solvent aggregated. When we add heat, it produces solvent particles separated. But heat of a solvent is greater than zero. Therefore, it's an endothermic process. The last step, solid solvent particles attract and mix to form a solution. This step is exothermic process. The separated solid particles attract the separated solvent particles and associate together to form a solution. In a solution, the solid particle distributed throughout the solvent particles. Separated solid particles plus separated solvent particles form solution. And as you see, the solid particle distribute throughout the solvent particle. Solid separated particle plus solvent separated particle, it forms solution plus heat. When we combine the three individual enthalpy changes to find the enthalpy of a solution, enthalpy of a solution is equal to heat of a solid plus heat of a solvent plus heat of a mix. This is the mathematical definition of enthalpy of a solution. Depend upon the relative magnitude of enthalpy of a solid plus enthalpy of a solvent plus enthalpy of a mix. Enthalpy of a solution can be zero. If it is zero, the solution, we call it an ideal solution. Enthalpy of the solution may be greater than, less than zero, it's negative, exothermic, and it may be greater than zero, positive, endothermic process. Ideal solution. Enthalpy of a solution equal to enthalpy of the solid plus enthalpy of the solvent plus enthalpy of mix, which is equal to zero. If enthalpy of solution is equal to zero, then the solution, we call it an ideal solution. When the intermolecular force of attraction in solid and solvent are the same, two solvent, the solution formed is called an ideal solution. In an ideal solution, no energy change. Solid plus solvent interaction almost equal to solvent interaction. During this time, the ideal solution is formed. Now let us talk about characteristics of an ideal solution. The first characteristics of an ideal solution is ideal solution obeys Raoult's law at all conditions. The second one, no heat is absorbed or released on mixing, means that heat of a solution is always equal to zero. The third one, no change in volume on mixing, means that change in volume of mixing is equal to zero. The fourth one, intermolecular force between the cell interaction almost the same. The components of an ideal solution are similar in chemical property. They are similar in chemical property. Let me give you a different example. A mixture of helium and argon is an ideal solution because helium and argon have similar chemical property. The second example, a mixture of methanol and ethanol form an ideal solution because methanol and ethanol has the same functional group, therefore they have the same chemical property and they form an ideal solution. The third example, mixture of pentane and hexane is an ideal solution because pentane and hexane have the same functional group, means that they have the same chemical property, therefore they can form an ideal solution. To summarize the property of an ideal solution: 1. It obeys Raoult's law at all conditions. 2. Heat of a solution equal to 0.